Section 5.5, Systems of Inequalities. Now in the previous section we looked at systems of equations, and a graph of an equation is just a single line. What's the difference between graphs of, or systems of equations and systems of inequalities? Well, equations will obviously have the equal to sign, and inequality will involve one of these comparison symbols. Greater thans, less thans, greater than or equal to, less than or equal to. So in graphing inequalities, we have one, I guess just kind of one extra step that we need to keep in mind, and that is that there is some shading involved. Graphing an equation just involves graphing the line. Graphing an inequality involves graphing the line along with one part of that shaded. Now we're going to work our way in getting to systems of inequalities, but to get there what we need to do is just look at some single inequalities to get used to how to graph the boundary line. Is it solid or dotted, and which side to shade to determine which side of the line we're going to shade. So we'll get started kind of slow here and work our way up to systems. So we'll work first with a linear inequality in two variables, then a nonlinear inequality in two variables. Linear here means we're graphing a line. The nonlinear ones we're going to look at will be parabolas. It's not a line. Then we'll look at a system of inequalities and then application. So first thing is, how do we graph a single linear inequality in two variables? Well, the solution is going to be that all the points whose coordinates satisfy the inequality, which means we'll have the boundary line along with some shaded portion. To draw the boundary line, we're going to replace the inequality symbol with an equal sign and draw or graph the resulting line. So we start off by taking out the inequality, putting in an equal to, and graphing that boundary line. Well, the boundary line is either going to be a dashed line, a dotted line, or a solid line, depending on the original inequality. Now notice it's going to be a solid line if it has the solid equal to underneath. So less than or equal to, greater than or equal to. If it has that equal to, we draw it as a solid line. If it does not have the equal to, we'll draw it as a dashed or a dotted line. Once we get that boundary line drawn and the appropriate solid or dotted, as the appropriate solid or dotted line, then we have to determine which side we're going to shade. And that's best done by picking a test point that's not on the original line. 0, 0 is always a good test point if it doesn't lie on the line, because it's easy to plug in. What we'll do is we'll take that test point, plug it into the original inequality, that means the one that has the less than or greater than, to determine true or false. We'll always shade the true side. So let's see how that's going to work out. So I want to graph the inequality 4x minus 2y greater than or equal to 8. Well, to get started, I have to replace the inequality with an equal to and graph the associated line. I'm going to graph this line, and since the original problem had greater than or equal to, this is going to be a solid line. The equal to underneath that comparison symbol means we're going to graph it as a solid line. So let's remember how to graph a line. We've got 4x minus 2y equal 8. Well, I need 2 points to graph a line. Now I can go several ways. Whichever way is the best way you remember how to graph a line. But very quickly, you could find 2 points for this line just using a quick XY chart by very easily finding the x-intercept and the y-intercept. Remember, for the x-intercept, you let y be 0. For the y-intercept, you let x be 0. We can very easily complete these two ordered pairs. So if I put a 0 in place for y, I get 4x equal 8. Well, we can easily solve that for x equal 2. 8 divided by 4. And if I put a 0 in place for x, I get negative 2y equal 8. And I can very easily solve that for y. 8 divided by negative 2 is negative 4. So we can very easily get 2 points on our line to graph the boundary line. So let's come over here and graph it. I've got the point 2, 0, and I've got the point 0, negative 4. So that's my 2, 0. and that is my 0, -4. And I'm going to graph that boundary line as a solid line. So I'll do the best I can at graphing that as a solid boundary line. Now, before this section we were done, but since this one has an inequality, we have one extra step, which is to determine which side to shade. Well, right here, we're going to pick the test point 0, 0, because 0, 0 does not lie on the line. So right here is 0, 0, and we're going to test it. It's a good test point. Not on the line, easy to plug in. We'll plug it into the original inequality, and I forgot a little statement here. Plug it into the original inequality to determine which side to shade. So let's take the 0, 0, the test point 0, 0, and plug it into the original inequality. So the original problem looks like 4x minus 2y greater than or equal to 8. So put a 0 for x and a 0 for y, and I'll end up with 0 is greater than or equal to 8, doing the arithmetic. Now I have to look at that inequality and decide, is that result true or false? Is 0 greater than or equal to 8? And it's not. So this test point, when I plug it into the original, comes up to be false. How will you know which side to shade? Because it said we'll always shade the true side. Well, I just found out that this side was false. My conclusion is going to be the opposite side must be true. One side is always true, one side is always false. So if this test point came up to be false, then I can gather that this side must be true, and that's the side I must shade. So I'm just going to pick a color here and got to show some kind of shading on that side of the line. Whoops, didn't want that to happen. There we go. Shade the true side. So graph the line as a solid or a dotted line and then decide which side to shade. Let's look at the next one. This one's not too bad. It doesn't involve quite so much algebra and actually graphing the boundary line here. So let's take a look at this. I've got x greater than 2. Well, I need to graph the associated line that goes with that, so I'll replace the inequality with an equal to, and I'll graph this boundary line. Let me get myself a little more room there. So we'll graph the boundary line, which is going to come from replacing the inequality with an equal to, x equal 2, and we have to decide if that boundary line is solid or dotted. Well, it's a greater than 2, it doesn't have the equal to, so it's going to be a dotted or dashed line. Now let's recall something from earlier in this semester. This is a real simple equation to graph. I just need to recognize a couple of things. Earlier, if we saw an equation y equal to a number or x equal to a number, we said that they were two specific types of lines. Y equal to a number was a horizontal line. X equal to a number was a vertical line. Well, those are easy to draw if I can recognize the format. X equal to 2 is just going to be a vertical line. So I don't need any extra points to plot. All I need to do is graph a vertical line at the number 2. So there's 2. I'll graph a vertical line, but remember it's a dotted line. So make sure when you do mark your line, you mark it as a dotted or a dashed line. There's the boundary line. Don't need to find any extra points. And now we'll just rely on just our basic information on how inequalities work. I now need to figure out which side to shade. Well, if I need to shade according to x greater than 2, and there's my boundary line, am I going to shade to the left of 2 or to the right of 2? It's pretty obvious to get something greater than 2, I'd have to go to the right. So I would show my shading on the right. So a dotted boundary, shading to the right. So recognizing those two forms is important.